Hey grade 10s, Mr. Martins here. Welcome to week 8 of this crazy COVID lockdown. And by now I'm sure you've heard that we are not coming back to school this year. What a crazy year it's been. In 30 years of teaching, guys, this is a very much a first for me, as it is I know for you as well. I know it hasn't been easy for some of you. I'm hoping that you still have time to get caught up on some of the work that I've given you throughout these 8 weeks. And you've probably noticed, hopefully, that last week I gave you the day off because it was a holiday, so I thought, why not? But I do invite you to go to week 7 because there is a nice little table here, guys, that summarizes everything that we've learned while we've been away from school. All right, so there's still plenty of time for you to get caught up on some of these things if you haven't done them yet. All right, so this week, which is now not next week, but week 8, which is for this week, we're going to be finishing off list for this unit. Also, you should know, and you may have heard this already, that after this week we're going to be looking at final projects already because we're getting into June, and the rule is that we're not supposed to be covering really any more new material after this week. So that means this is the last week that we have to learn new things. Now, if we were in school right now, guys, there would be a lot more I could have shown you with regards to Pygame and writing our own video games, but we just didn't get a chance to do that in our COVID situation. So we're going to instead have you do a final project that's going to be in Tkinter and just working with the things we've learned throughout the course up until and including this week, which is to finish off lists. All right, it'll be still kind of a game, like a trivia type game, so it'll still be kind of fun, but obviously not quite the same as Pygame. But excuse me. But I just wanted you to at least have enough background information so that if you do decide to come back for grade 11, you've got the basics down. We don't need Pygame for grade 11, so we'll have enough knowledge that we can move forward. All right, so this week, let's talk about that. In week 6, which was 2 weeks ago, we did this big worksheet on lists that you were to finish and hand in to me, along with one program which we did, which was the list of email addresses and names. It was sort of a menu-driven program that keeps track of a list of people that you know and their email addresses. So we need to spend more time this week working with lists, okay? So we're not really going to learn anything new this week as much as we're just going to recap the list because it's a really important part of programming, and it's going to be an important part of your final project starting next week. So I wanted to spend a bit more time with lists this week. So the first thing I'm going to do, guys, is I'm going to just go through the slideshow with you really quick. And it's on D2L in week 8, so you can always look through this on your own if you need to as well. Okay, and this is just a recap of all of the list things that we learned, I guess, 2 weeks ago at this point. All right, so we'll just go through, and hopefully this all jogs your memory. All right, so if you recall, a list is basically a variable that points to a list of values. So it could be a list of numbers, or it could be a list of words, okay? If we want to work with the list, so here's my 2 lists here in the sample program, there's a few things I can do. I can find out the length of each list to find out how many are in each list. I can look at individual items in the list if I provide an address beside each list, so a square bracket. Actually, let me go with my pointer here. That's a little bit better. My square bracket with a list location. Now remember from 2 weeks ago, list locations start at 0 and they go up from there. All right, so mark 0 would be the 78. Students 3 would be Sue, which is location 3 in the list. All right, and then we're just printing some things out here. A for loop is the best way to travel through a list, and there's 2 ways we can do that, which we'll go through again. So this is just a for loop that travels through each of the students and the marks at the same time, and then we end up with this particular output from this program. Now this isn't an assignment, this is just kind of a recap. You're more than welcome to try it if you want to, just to get more practice, but it's just there for you to look at. On the next slide we get a better look at the locations. All right, so here again are those 2 lists, and you can see this little table kind of summarizes the locations of each item in the list. All right, so here's a reprint of that part of the program where we're just using this for loop, and the list numbers 0, 1, 2, 3 are basically captured in this variable x in a for loop. We learned about for loops about a month or 2 ago, so I'm saying let x equal the numbers 0, 1, 2, 3. So if I say student x or mark x, I'm basically traveling through all of the locations of both and then printing them so that you see this class list here. All right, so that's basically how lists work. The rest of the slideshow kind of gives you some more finer points, like if we want to add or remove from a list. Okay, and also, oh yeah, I forgot about this. So I also showed you another way we can get through through a list. So all of these examples kind of do the same thing. So there's a traditional for loop where I can say let x equal the numbers 0 to 3, and then I can travel through, use location x along the way. I can also say for x in students. So now x isn't a number anymore. X represents actual students in the list. Okay, so notice my placeholder now isn't students at location x, it's literally just x. So I'm saying let x equal each student. And you see how it says S takes the class. Okay, so Bob, Amy, Joe, and Sue takes the class. So that's the output of this little piece of code here. All right, and I do the same thing with y. I can use a traditional for loop that goes through a range, or I can say let y equal each mark in the marks list. So when I say somebody got a %D, y is literally each mark in the list. So I got 78, 64, 91, and 84. If I want to combine these two into a sort of a technique that touches on both of them, I can use this zip command. So I'm saying let x equal each student, and at the same time let y equal each mark. And then I use zip to sort of bring the list together, and I can say %s got a %d. So x is each student and y is each mark. So then you end up with this output here. All right, so you'll see me from time to time use both of these, and in our assignments for this week I'm going to use both of these techniques again, just to show you the different ways you can get through. I like the for y in for x in better because it's a little bit easier. Like you see the typing, it's a lot easier to just do it this way rather than using a for loop where you're having to put the name of the list and then the address in square brackets. However, this is not a way to do it if you need to get to each of these things and say modify them. So for example, say I wanted to go to each of my marks and add 10% to them. Okay, this is kind of a read-only way. This will print each mark and access each mark. But if I add 10% to this variable y, that's not going to get back into the list of marks. So y doesn't have the ability to go in and change a value in marks. Okay, y just sort of copies each value out of marks so we can print it, but that's all I can do. If I want to actually dig in and get each mark and change it, I have to say marks at location whatever equals marks at location plus 10% or something along those lines. Anyway, you'll see that as we go through. So for x in, y in, this is good for read only. The traditional x in range is good if you need to get to each thing and do more than just read from it. If you want to change it in some way, then you got to use this x in range technique instead. All right, so next, another example where we are finding the average of a bunch of marks. So I can either say for x in range 0 to 4, because all I'm doing in this example here, guys, is I'm reading the mark, each mark, and adding it to the total. Okay, so I can do it the old-fashioned way, like the traditional way I'll call it, or I can say let mk equal each mark in marks, and I can say total plus equals mk. So either way, it's going to work in this case because I'm only reading from it. And then I get my total is adding up all the marks, and then I say average equals total divided by how many marks I have. So I could either put the 4 here, or I could say len marks, which is also 4, and then I'm just printing the average. And either way, I get the same answer. All right. Okay, so now we're going to look just quickly at adding and removing from the list. So there's two ways that you can add to a list. You can use the append command. So the append command adds something to the end of a list. All right, so if I say students.append Drew, and then his mark is being appended to the end of the marks list. Okay, so you'll notice that if I print both of those lists again, you'll see those new things added to the end. All right, I can also insert into the list somewhere in between or somewhere along the way. If I supply a location, so I'm inserting at location 2, the student Karen, and then marks location 2, because I want to make sure the mark is in the same spot as the new student. I can say insert 66 at location 2. All right, so then if I print it again, you'll see that Karen is at position 2. Now remember, it's 0 base, so it's actually the third. Like position 2 is actually the third position in the list. So Karen gets squeezed in there. Karen's mark gets squeezed into the same location in the marks list, and everybody else gets pushed over. All right, so append works, insert works. With insert, you got to also give a location so it knows where to insert it, and append automatically goes to the end. All right. We can also look for where something is in a list. Okay, so this example here, Amy location equals students.index. So the index command can be used if I supply a value to the list. It'll tell me where that student's located. Okay, so Amy is at location, and then in this case it's at location 1. Okay, so this variable Amy location is actually the number 1. So I can actually plug it in as a location into the marks. Okay, so I want to update her mark to 77. This, first of all, finds out where Amy is in the student list, so then I know where her mark is in the marks list. So then I'm saying marks at that same Amy location, which is 1 in this case, equals 77. Alright, so I'm updating the marks, and you can see that her mark is now a 77. So that's another technique you can use to search through a list. Alright, removing from the list, just like adding to a list, there's 2 ways to remove from a list. Okay, we can remove by location. So if I know that Sue is in location 4, for example, I can just pop number 4 and then marks pop number 4. And you can see here how Sue is going to be eliminated, and Sue's mark will also be eliminated at the same location. Alright, and then when I reprint students and marks, you can see that Sue and her mark are both gone. Alright, so that's one way you can do it. Now what if I don't know where Sue is? Like I could search for it. Like on the previous slide, I can use this index to find out where she is first and then pop that location. Or I can do it a different way using the remove command. Okay, so here's a separate example. We're not using student list anymore, but say I have a list of 4 fruits, and I know pears is in there somewhere. I could go searching for it, or I can just say remove and then supply the thing I want to remove. So I don't need a location here. It'll search for it on its own and then remove it. Alright, but you got to make sure it's in there, because if you try to remove something that's not there with the remove command, you'll get an error. So it'll just kind of give you all that red text that you've seen when you get errors. So you got to make sure you're removing something that already exists in the list. Okay, so this last slide here, guys, is a nice summary of adding and removing. Okay, so you can add to the list by using append, which goes to the end. You can also add to a list using insert, where you give a location and it'll squeeze it in there. You can remove by looking for an actual item, so you can type in the name or the number that you're looking for to remove. Now in the case of, like, say it's a bunch of numbers and you want to remove the number 57, if there's more than 157, it's only going to remove the first one, so you got to be careful. Like, this is assuming you've got different things in the list, that there's no 2 that are alike. But either way, it'll work, but it'll just remove the first thing it finds that matches the item. So fruits remove grapes, for example. Alright, if you happen to know the location of the item, then you can say pop and provide the location, and it'll just pop whatever's at that location, assuming that that location exists, right? So if you have 10 items and you're trying to pop item 20, then obviously you'll get an error as well, because there isn't 20 items in the list. Alright, so that's just a quick little summary. Nothing to do in this video other than to listen to me go on about lists. So in the next video, we're going to do one of the 3 programs that we're going to do for this week. Alright, which will be like a tkinter, not a tkinter, sorry, an idle shell. Now there is 2 more slides on this, and you'll notice them. So there's this one here which talks about sorting and max and min. So there's a few other things here you can do with lists, but I'm not going to go into those in too much detail, but you're welcome to look at those as well. And then, oh yeah, so there's this as well. Sorry, I forgot about this last thing. Because we're going to use this in one of our assignments. So say I have a bunch of fruits and I want to get a random fruit, okay? I could definitely do it this way. So I can say, print, I put a %s in the bowl, so fruits at random location f, right? So if f is a random integer from 0 to 4, it'll just pick a random fruit out of the list. Okay, another way we can do that, though, and this is what we're going to do in our Magic 8-Ball program later on, is we're going to use r.choice. So random r also has this ability to use the choice command. When you send in like a list of something, it'll just randomly choose one of those fruits. Okay, so this is a different way to do it. Okay, so both of these programs do the same thing, but in this case we're choosing a random int f and we're plugging it in as a location to fruits. Here I'm just using r.choice, and it'll just pick its own random fruit and store it into f here. So in this case, f is a random number, okay, and then we use it in the list. Here, f is an actual random fruit, okay, and then I can just print f directly rather than fruits at location f. Whoops, sorry, go back here. Alright, so this will come in handy when we do our Magic 8-Ball later on. Now there is one more assignment here which we're not going to do this year under COVID lockdown in Saltogram. You can certainly try it if you want to. It's kind of a fun program where you just click the button and it randomly insults you by plugging together random words from 3 different lists and puts them together into a sentence, but that's not what we're going to do. We are, however, going to do this one later on. All right? So that's enough for this video, guys. In the next video, we're going to start with our first of the two programs that are not tkinter. Okay, so these are the idle shell assignments. So there's two of them here. I want to work with you together to finish. There's the below and above average, and there's the hotels pie. All right, and then our final video of this week will be looking at the magic 8-ball assignment. All right, so we'll see you back for part 2.